Starting with 7.4, you will learn about annuities. So, what you will learn is how to calculate the value of an investment after regular payments are deposited into an account. An annuity, or what annuities are regular payments of an equal amount that are made over an equal period of time. And you can also say it is the sum of money paid in a series of regular payments. There are two different types of annuities. There are ordinary annuities. This is where the payments are made at the end of each payment. And there are ordinary simple annuities, and that is where the compounding and payment periods are the same. The equation that we use to calculate annuities is A is equal to R square bracket 1 plus I to the power of n minus 1 bracket divided by I. In this equation, A represents the future value of the investment. R represents the regular payments made at the end of each period. I represents the interest per compounding period. And N is equal to the number of payments made. Another equation that can be used is to calculate the amount of payments that you need to make at the end of each period. This equation is R is equal to future value times I divided by bracket 1 plus I to the power of n minus 1. With this equation, you're able to calculate the amount that is regularly invested into that account or put into the account in order to get that specific future value that is given in the problem. Now to try this practice problem. Johnny deposits $500 into his account at an interest of 3% per year compounded semi-annually. He makes deposits into his account for 5 years. What is the amount in his account after 5 years? Now, knowing the equation FV is equal to R bracket 1 plus I to the power of n minus 1 divided by I, we can see from this equation that we are given the R value, which is $500. We are given I, which is 3%, which can also be 0.03. We are also given the N, which is 5. But knowing that it is compounded semi-annually, you must multiply the N by 2. So this would mean that the number of payments is 10. And also, based off of our interest, which is 0.03, we have to divide that by 2 since the compounding periods is semi-annually. So that's 2 times per year. So we must divide the interest rate by 2. Knowing that, we can now start, knowing these values, we can now plug them into the equation to solve for the amount of money that is in the account after 5 years. So FV is equal to 500 times, or bracket, 1 plus 0.03 divided by 2 to the power of 10 minus 1 divided by bracket 0.03 divided by 2. So after punching the terms into the calculator, you will see that the top row will be 80.27 divided by the bottom row, which will then turn into 0.015. Now when you divide these two terms, the answer you should get is 5,351 decimal 33. So therefore, after 5 years, Johnny has $5,351 decimal $33 in his account.